After studying this module, you shall be able to know what are the various uses and forms of ANOVA, identify the differences between one-way ANOVA and two-way ANOVA, know about the assumptions and procedure of ANOVA and evaluate its context of usage and applicability, and know the different models of two-way ANOVA, understand the numerical use and application for ANOVA, followed by SPSS use of ANOVA. With changing times, people have become more conscious of their physical health and appearance. Various exercise patterns have come up to lose weight and stay fit, whether it be our childhood beloved rope skipping or six-pack building push-ups or the much more exciting and enjoyable aerobics. But how do we choose which exercise is effective for losing weight quickly? One can find that out in a scientific way by comparing the weights of the individuals doing each of these exercises after a specific period of time. We might take 5 females doing each of these exercises and compare their weights after 4 weeks to find the effect of the exercises. Here we bring ANOVA to compare the 3 groups. After the suitable statistical analysis, the researcher would come to know if there is a significant difference between the various exercise programs and a suitable application of the results can be made. Analysis of variance. What is ANOVA? A statistical model used to compare more than 2 conditions is called ANOVA, or the analysis of variance. The readers must know that a t-test is used to compare 2 means only. This is because if one was interested in comparing 3 experimental conditions and if one was to carry out t-tests on each pair of groups, then one would have to conduct 3 separate tests on comparing group 1 and 2, other comparing group 2 and 3, and the last one comparing group 1 and 3 again. One would also recall the concept of type 1 and type 2 errors. With each statistical test, the probability of occurrence of these errors, that is type 1 and type 2, increases too. Let us explain this and understand how we say that the probability of error increases with each application of the t-test. Suppose at a 0.05 level of significance, the type 1 error or the probability of falsely rejecting the null hypothesis is only 5%. 0.05 level of significance, 5% probability. Thus, the probability of no type 1 error is 0.95, that is 95% of each test. If it is assumed that each test is independent, one can multiply the probabilities, giving an overall probability of no type 1 error as 0.95 into 0.95 into 0.95, which comes to 0.857. As the probability of no type 1 error is 0.95 for each test and there are 3 tests, the probability of making it at least one type 1 error becomes 1 minus 0.857, that is 0.143, that is 14.3, increasing the probability of making type 1 error from 5% to 14.3%, unacceptable to social scientists. So, we say ANOVA is a better choice than applying 3 t-tests to the data. Now, it is clear that with increasing number of comparisons, the probability of errors increases too. As the number of groups for comparison will increase, the number of t-tests to be carried out will also increase, and along with it would increase the error rate. Therefore, ANOVA is brought to rescue us from these situations, and this is the one-way ANOVA discussed in the earlier module. The one-way ANOVA compares 3 or 4 more levels of one factor. With increased number of factors of variables, the research designs become more complex. The researcher resort to factorial design most of the times, and the higher order statistical procedures too. So, in this case, we move from one-way ANOVA to two-way ANOVA whenever we take a factorial design. Now, what are factorial designs? When an experiment has two or more independent variables, it is known as a factorial design, with the variables being referred to as factors. Factorial designs can be independent factorial design, the one which involves several independent variables or predictors, and each has been measured using different participants, like between groups design. The repeated measure factorial design involves several independent variables or predictors, but the same participants are used in all the conditions. The mixed design involves several independent variables or predictors, some measured with different participants and the others using the same participants. For details of these designs, I advise the readers to refer to modules number 3 and 4, which give a detailed discussion on the concepts of research designs. What is two-way ANOVA? When one uses ANOVA to analyze a situation in which there are two or more independent variables, it becomes a factorial ANOVA. The two-way ANOVA extends one-way ANOVA to include two independent or explanatory variables. It is like an experimental study that gives numerical results with two explanatory variables which are categorical in nature. The independent variables are referred to as factors and may have further levels. It is assumed that the dependent variable is affected by two factors. A subject may be exposed to a level of each of the two explanatory categorical variables, as there are two independent variables involved. The impact that change in an independent variable may produce on the outcome may not be related to the independent variable. Let us explain this with the help of an example. A company wishes to understand the occupational stress in response to age and gender. The dependent variables become occupational stress, age and gender become the two independent variables. If the employees are categorized according to the age groups into age less than 40, 40 to 55 and above 55 years, in addition to the gender classification being male and female, the design requires the use of two-way ANOVA. Here the factor has 3 levels and the factor gender has 2 levels. This implies there are 3 into 2, that is 6 groups or cells. And on this layout, one obtains the occupational stress scores from the employees categorized in the 6 cells. Now the basic version of ANOVA shall have one observation in each cell, which is that of occupational stress scores from one employee in each of the 6 cells. At the same time, the other versions may have more than one observation per cell, but it requires the number of observations in each cell to be equal. This helps in testing if there is any interaction between the two factors like age and gender interacting together to affect the level of occupational stress. It also lets one know if age and gender are independent of each other, such that the effect of age, for example, remains the same irrespective of the gender being taken into account. The types of two-way ANOVA. Two-way ANOVA can have different subtypes. 2 of them are two-way repeated measures ANOVA, that is the 2 independent variables both measured using the same participants, and the two-way mixed ANOVA, in which 2 independent variables, one measured using different participants and the other measured using the same participants. Assumptions, models and procedure for ANOVA. Assumptions of two-way ANOVA. The two-way ANOVA as an analytic method is appropriate for a study with quantitative outcome and 2 or more categorical explanatory variables. The following assumptions are followed. Keeping in mind these assumptions, the researcher may decide whether to apply ANOVA to get valid and reliable results or not. The first assumption is of normality, and it is assumed that the parent populations from which the samples have been drawn are normally distributed. Independence, the chosen samples are independent of each other. The next assumption is homogeneity of variances, which assumes that the scatter of scores or the variance among the samples is uniform, or in other words, the obtained scores are uniformly scattered around their means in each sample. Sample size also has an assumption, and it is important that the samples are chosen of the same sample size for all the groups. The models of two-way ANOVA. The two-way ANOVA might have different models to its disposal. The first is structural model with interaction. The structural model of ANOVA suggests that the combination of explanatory variables being explored have their respective populations with corresponding means. The interactive patterns of these means may follow an arbitrary pattern. This would imply that the outcome produced by changing any one variable may depend upon the levels of other variable. The no interaction additive model is the model places conditions on the population means of the outcomes. The change for one explanatory variable is supposed to have same effect on the outcome for every other explanatory variable. In other words, one may add that the outcome of change in an explanatory variable does not depend upon the level of other variables. The procedures of two-way ANOVA. To begin with, two-way ANOVA requires formulation of hypotheses, which are the first factor population means are equal. The second factor population means are equal, and the two factors do not show any interaction. The treatment groups are then formed by making all possible combinations of the two factors. For instance, if the first factor has 3 levels and the second one has 2 levels, there will be 3 into 2, that is 6 different treatment groups. For instance, one can assume the treatment of a particular psychological disorder. The type of psychotherapy and the medication being used for treatment of that disorder are taken into consideration. There are 5 types of psychotherapies, and one has 3 types of medication one is going to use. Therefore, this group will have 15 treatment groups. So, the degrees of freedom for the groups would be type of medication equal to 2, that is 3 types of treatment medications were there, minus 1 equal to 2. For types of psychotherapies, the degree of freedom would be 4, 5 minus 1. The DF for the interaction between medication and psychotherapy would be 2 into 4, that is 8. Look into the exhibit given below, and this describes how the data would be arranged for ANOVA and how different treatment conditions are put for both the factors and how the degree of freedom would be taken. The main effect will involve the independent variables one by one, taking into account only the rows and columns and not mixed similar to ANOVA. The interaction effect is the effect one factor has on the other factor, degrees of freedom being the product of the 2 degree of freedom for each factor. Within variation, the sum of squares within each treatment group, that is 1 less than the sample size of each treatment group. The total number of treatment groups is the product of the number of levels for each factor. Within variance is the within variation divided by degrees of freedom. The F-test is done for each of the hypotheses, that is the mean square for each main effect and the interaction effect by within variance. The advantages of two-way ANOVA are, following are the advantages of two-way ANOVA. They have a usually smaller total sample size. It is more efficient to study 2 factors at once rather than studying them separately. Two-way ANOVA removes some part of the random variability, as the random variability gets explained by the second factor, easing the search for significant differences. Also, two-way ANOVA studies interaction between the factors and can be looked at finding the effect of change in one variable with the level of the other factor. Statistically, significance can be obtained for each factor for interaction effect or any combination of these. So, two-way ANOVA proves to be more useful. The exhibits given below show the results of two-way ANOVA. Applications of two-way ANOVA. The two-way ANOVA is applied to the data when the researcher wishes to study the effect of multiple levels of single independent variable or factor on a dependent variable. The simultaneous analysis of two independent variables can be carried out, saving on the expenses and resources for two separate researches. And also, two-way ANOVA helps to generalize results better and have a broader interpretation of the results. Some of the highlights of applying ANOVA to the data are the focus of analysis for ANOVA. The purpose of two-way ANOVA or multifactorial ANOVA is to analyze the mean differences across main effects, interaction effects and simple effects. The number of independent variables involved here would be referred to as factors, and it is explanatory enough that more than one independent variable is involved in multifactor ANOVA. The scales of measurement used for dependent variable should be continuous and it should either be in interval or ratio scale. The relationship of the participants across the groups being measured in multifactor ANOVA, the participants may be used for within group, that is the related subjects, or between group, that is the independent design. So, you may have a related subjects ANOVA or between group, that is the independent design, if you want to use ANOVA. Assumptions. The dependent variable must meet the assumption of normality, homogeneity of variance and covariance. Independence of scores is also taken into account. After understanding all this about two-way ANOVA, let us move into the most important thing, that is the numerical application of ANOVA. Let us begin by explaining the problem to which ANOVA can be applied. A researcher wishes to study the relationship and effects that an exercise schedule, which is measured in length of the exercise regime, has on the flexibility of genders, that is measured as males and females. The levels of exercise schedules are 1 week, 2 weeks and 3 weeks. The dependent variable is the score on measure of flexibility, and higher score indicates higher level of flexibility. The mean and standard deviation for the flexibility measures as a function of the two factors are represented in the exhibit below. We can see for both the genders and for the 3 weeks exercise regime what is the mean and standard deviation, where the standard deviations are shown in brackets. The results of the two-way ANOVA indicated a significant main effect for the gender, that is the F ratio was 22.37 at a probability of 0.001, and a significant main effect for the length of exercise program. For F it was 36, F for 242 was 36.03 with a probability of less than 0.001. The results in addition also showed a significant interaction between the gender and length of exercise program, which was 11.84 with the probability checked at less than 0.001, indicating that any differences between the length of exercise programs were dependent upon which gender the subjects were, and that any differences between females and males were dependent upon which length of exercise program they were in. Approximately, there were 14% of the total variance of the flexibility levels was attributed to the interaction of gender and length of exercise program. The two-way ANOVA for flexibility level, the results are shown in the table below. We find the source of Sum of square, degree of freedom, mean square, F ratios are calculated and the probability is also shown. The duration of exercise schedule, gender into duration of exercise schedule, within group error are also shown here. The interaction effects are also shown graphically, and we find that the results of ANOVA show that interaction between duration of exercise schedule and the gender is significant. Let us study the gender effects first, that is the difference between the males and females on the 3 levels of the duration of exercise schedule. The significant differences have been reported only on the 3 weeks duration schedule. Females had significantly higher level of flexibility also. One also studied the duration of exercise schedule, main effects, and the results are there in the table. One can check out that the females in the 3 weeks duration had significantly higher flexibility than the ones in 1 week duration. Similarly, for the males, the results showed 1 week duration to be significantly different from the 3 weeks duration on flexibility. Using IBM SPSS 20 for two-way ANOVA. A researcher would like to explore the habit of leaving the treatment over and again among the drug addicts. The study was designed to understand a behavioral intervention called contingency management can improve treatment retention compared across prior treatment among the drug abusers. 120 drug abusers, both male and female, were taken which were using drugs and seeking treatment for over 10 years. The 2 independent variables were treatment conditions with 2 levels, that is the standard care, and the other one was standard care plus contingency management. And the other independent variable was the treatment status, that is the number of prior treatment attempts that the subject has availed. The dependent variable was treatment retention, which was measured as the number of successful weeks in the treatment process. The 2x2 factorial research design has been used, and the obtained data were used to prepare the data sheet, and the following SPSS commands were used to get the two-way ANOVA results. Once the data sheet was prepared, then one clicks on Analyze, click on General Linear Model, click Univariate, click over Treatment Retention under Dependent Variable, and Treatment Condition and Treatment Status under Fixed Factors. Click on the Plots button, click Treatment Condition to horizontal axis and Treatment Status to separate lines. Click the Add button, click Continue. Click on the Options button, click on the boxes of Descriptive Statistics, Estimate of Effect Size, Observed Power and Homogeneity Tests. The significance level should be 0.01. Click on Continue and click OK. Save the generated outputs as two-way ANOVA results. The summary of the text. The two-way ANOVA technique is used in case of the data being classified on the basis of 2 factors. It may have repeated measurement of each factor or may not have repeated values. It has extreme utility in the fields like social science, economics, biology, business and other disciplines. Where the Z-test and T-test judge the significance of difference between means of 2 samples, ANOVA helps perform simultaneous tests on more than 2 sample means at the same time. Using two-way ANOVA, one can study how various factors interact to produce a certain outcome. Two-way ANOVA or the factorial design ANOVA follows additive and interaction models to understand the effect of independent variables on the dependent variables. It has widespread applicability in areas of social sciences, industrial research, and since most of the phenomena in today's world are not affected by one or a linear relationship, multiple factors are known to cause a particular phenomena, and the effect of these factors may act individually or in conjunction with each other. The IBM SPSS 20 instructions for using two-way ANOVA are also given in the text.